Hello and welcome back to Inside Electronics. So in this episode, let's try to repair a common fan regulator. Now this is a capacitance based step dimming fan regulator. So this is the very simplest form of fan speed controller that you can buy. So I still prefer the old one, the triac based one, but you can still buy them, but only in a limited number of shops, at least where I live, because most of them are moving towards these kind of capacity based cheap dimmer circuits. Now granted, these are available under popular brand names as well, and also in no-name Chinese cheap brands. Price is actually bigger for the branded one and cheaper for the Chinese one, but they both do the same thing. It's basically the same circuit inside. So right now let's see how can we fix one of these. Now the first thing we need to check for is the capacitors. Now let me undo this bolt and I will show you what's inside it. Well, here you go. This is the inside of the fan speed controller, and being an item that is used a couple of times at least in a day, chances of this thing getting damaged is really high. And the most common problem with this is the rotary switch itself, because in the case of the SCR triac based dimmer circuits, it's actually a linear or logarithmic potentiometer that has a smooth motion to it. But in this case, this is actually a step selection switch. It's actually a rotary switch. This is not a potentiometer. This is just a rotary switch. So chances of getting this thing damaged is very high. So if this is the thing that is damaged in your item, then you better purchase a new item, because this thing, it's really hard to come by these things. The second thing you have to check for is the capacitors. There are 3 capacitors in here. The lowest value will be 1 microfarad, followed by 2.2 microfarad. I hope you can see that. 250 volt. There is some burn mark in here that suggests that gives me a hint about the problem. Okay, anyway, the third one is actually 3.3 microfarad, 250 volt. So to check these capacitors, you need to have a multimeter that has a capacitance measuring function, or you need to have a dedicated LCI meter or something that measures capacitance. If you don't have any of such meters, all you can do is actually take a chance, purchase 3 new capacitors and get it replaced. It's actually much easier to identify the issue with the capacitors, because when they go bad, they actually explode. It's not like it looks pristine like this and it's shorted inside. If they go bad, they actually explode and leak, and basically it gives a visual indication that it is bad. Now the next thing that can go bad in circuits like this are the low value resistors that are connected in series to the capacitors, the value of which can be different based on different brands. But anyhow, you have to test it with a multimeter and make sure that it actually reads the proper value. If it shows open, then you have to replace it with the correct value resistors. So if all of them turns out to be okay, then you have to check for the circuit. Now in this particular case, it looks like some kind of corrosion is there on the board, that coupled with this soot mark in here. Can you see that? I think there is something blown in here, but I'm not seeing anything obvious. So, and mind you, there is a break in the cable. So in such cases, you need to check for the continuity. So let's start using a multimeter. Let's put it in the continuity mode, and we need to see whether the wires are all fine. So there you go. This wire is fine. That was the one with the break, so that break was not the problem. And this wire goes to here, that is also fine. So it's not about the wires, but if you take a look in the board, you can see it's not a very good solder joint. You can see it can come out at any moment. There is not enough solder in there. Hey, look at that. It looks like there's a track missing right here. Okay, that explains. Okay, I think that explains the soot mark. There is a track missing right here. So we have found the problem with this one. So let's connect that together and let's see whether this thing comes back to action. And in the meantime, when the soldering iron is getting hot, let's clean the board.
When you're servicing something, when you're repairing something, it's always better. It's always a good idea to clean the board if you find it to be too dirty, because it always helps. Sometimes there won't be any kind of problem except the board needs some kind of cleaning. Like in the case of SMD components, the board has some SMD components in that. Chances are corrosion can really affect those kind of things in a bad way.
There you go, you can now easily see the track that is missing. So I'm going to solder a fuse link to it first. Alright, now the track is shorted using a piece of copper wire as a link. You can see over there. Now this doubles as a fuse, just in case if something decides to blow up. I hope it should be that fuse link. So it's a good idea to always, when you're making this kind of modification, it's always a good idea to use a piece of wire link, a strand of wire, as an initial test. And if everything seems to be alright, then you can make a direct contact. So now enough of talking, let's see whether the modification has worked or not. So let me connect it to a bulb. I have a fan here in standby, so let's check it with the light bulb and the fan too. So let me connect it and I shall come back after that. Alright, now I have made the connection, so let's see whether it has worked or not. So I'm going to turn it. There you go. We're going to increase the brightness. Something is wrong with this mode. In fact, it is glowing. If I remove the power, you can see the filament is still glowing, but I'm not sure why. Probably something wrong with the switch. But this is the fourth mode and the direct mode. You can see everything is working just fine. So now let's connect it to the fan and see whether the fan, how the fan reacts, because these kind of fans are not supposed to be speed controlled, but let's see. And there you go, the fan is now connected and I'm going to turn it on. And I'm not sure what is going to happen, because as I said, this type of fans are not designed to be speed controlled. So let's see. Yep. No, it does not like that. It does not like that. It's trying to spin up. Let's see. Oh, it's acting like, nope. I might probably kill that. It's acting like more like a DC fan. It's attracting to it itself. So yeah, clearly it's not supposed to be speed controlled, so obvious. So that's it. This speed controller is now fixed, and that is how you can fix yours if it seems like it is not working. So thank you for watching, guys. See you with another video.